So now what we're going to do is we're going to talk about the async task barrier framework. And I'll explain to you what this does, why it is useful for all of the case studies we're going to look at, but perhaps more importantly, why this abstraction is useful for other kinds of asynchronous processing with reactive streams frameworks in general. This framework provides a single place, a single location in your program that can be used to wait for the completion of a bunch of asynchronously executing test methods, or more broadly, just methods that do work. And there's implementations for both Project Reactor and RxJava. We're going to focus on the RxJava example here. So as you'll see, for those case studies I was telling you about before, there are a whole bunch of test methods that we're going to run. And these will be running typically asynchronously using something called the subscribe on concurrency operator. And what that means is that the methods, when you call the test methods, the test method will return before the computation that's kicked off by the test method actually completes. And we'll talk more about this later, but that's really the purpose of the subscribe on operator. It allows the computations to run in the background. You can think of subscribe on a little bit like the supply async method that's available in completable futures. It's not quite like that, but it's the same basic idea. You're scheduling something to run in a background thread from a pool of threads, which could be defined in various ways. There's a whole bunch of different ways to have different kinds of schedulers that have different thread pools. So why is this an issue? Because if we don't have some way to wait for all these asynchronous computations to finish, then our test program will fall off the end of main before all the asynchronous computations running in the background complete, which of course will cause all kinds of chaos and insanity. So we therefore, because the program will shut down before the computations are done, which is not going to be helpful in the least. So it is more helpful, therefore, to define this one location in the driver test program that will wait for all the asynchronously executing test methods to complete. And you can see here, here's our main program, which you could take a look at here in this example. And then we're going to register a whole slew of test methods with our AsyncTaskBarrier singleton. And this will then let all those test methods start to run asynchronously. So we can start them all running, and they'll go run in the background, cranking away in their own threads in the pool of threads that's defined by the scheduler. And then we can wait for all those computations to be done by making a single call to blocking get. And this again will ensure that we don't fall off the end of main on the main thread in the program, the test program, until all the asynchronous tasks complete running. You can kind of think of this a little bit like the use of the completable futures collector that we've been looking at. Like if you look at assignment number 4, program assignment number 4, you can see we had that futures collector int stream abstraction. This is kind of along the same lines as that, where you can have a single point where you wait for lots of asynchronous things to complete, to finish. So basically what we have here is we have a framework, which is a set of methods that are going to collaborate to provide a reusable architecture for a family of different use cases that involve running tests and other operations asynchronously and ensuring that the calling thread doesn't exit until all the asynchronous processing is completed. And again, we'll talk more about this once we've talked about the different operators in RxJava. We'll actually look at the implementation of this framework. It's really cool. It's really interesting. So that's the end of the overview of the AsyncTaskBarrier framework.